Hey everybody, this is Unit 1 Formative 2 Video 5, Variables on Both Sides of an Equation. Alright, so this is what it looks like if we have variables on both sides of our equation. And it works very similar to what we have done with two-step equations and multi-step equations. First, let's draw our line by the equal sign to separate both sides. And what I like to do is move the smaller variable. So in this case, the 2x is going to be our smaller variable, and we're going to want to move that over here. It doesn't matter whether you move the 5x, it's going to work the same way. Now, remember how we would move a constant? It works the same way with a variable. So it's a positive 2x, so I'm going to subtract the 2x over. 5x minus 2x gives me 3x plus 2. These canceled out, equals 14. And now it's a two-step equation from here, so we can subtract 2, 3x equals 12, divide by 3, so x equals 4. Alright, the other way you could have done this is by actually subtracting the 5 first. And if you would have done that, you would have subtracted the 5 here. And then these would have canceled out, so we would have had 2 equals 2 minus 5 now is negative 3x plus 14. And we want to subtract the 14. So negative 12 equals negative 3x. Divide by negative 3. And you still get x is 4. Okay, so either way is going to work, whether you move the variables to the left or the right side first. I just like to move the smaller one so that the variables are going to be positive if we can make them that way. Alright, next one here. We have distributing, if you notice, with the parentheses on both sides of my equal sign. So I'm going to draw a line here, and if we distribute the 2 to the 5x and to the negative 1, because this is a plus a negative 1, remember, we're going to get 10x plus negative 2 equals, do the same thing with the 3x plus 33. Okay, now this one is very similar to the last one at this point, so we can move the 3x over, so subtract 3x. And notice I picked the 3x to move because if I take 10 minus 3, that'll give me a positive 7x. If I would have moved the 10 over, it would have given me negative 7 on the other side. These canceled out, so equals 33. Add the 2. 7x equals 35. Divide by 7, so x equals 5. Alright, next one here. We have a minus sign right here before the parentheses and a minus sign in the parentheses. So first thing we're going to do is change this to a plus. And think about having a negative 1 on the outside there. Change this to a plus, make it a negative r. Alright, so that gives me, now I'm going to distribute the negative 1 to inside the parentheses. So 2r plus negative 5 plus negative 1 times negative r just gives me positive 1r equals 13 plus 2r. Alright, draw my line down by the equal sign. Now, if we look at our left-hand side of the equal sign here, you notice you have 2r and 1r. So we want to combine those together first to get 3r plus negative 5 equals 13 plus 2r. Alright, now if you look at your r's, you have 3r here and 2r here. If I were to subtract the 3r over to this side, I'll get negative 1. But this is a positive 2r, so I can move it over here by subtracting 2r, and then I'll have 1r plus negative 5 equals 13, because then these will cancel out. So now my r is positive, which makes it a little bit easier. Add 5, so we could just say 1r equals 18, or just r equals 18, because you don't need to worry about the 1 in front of the r. All right. When we look at variables on equations with variables on both sides, you can get something called an identity. This is when all your variables end up canceling out and you're left with something like 4 equals 4. So you're left with a true statement. That means that basically all solutions or all numbers are solutions. Okay? If we have one solution, it's exactly what we've been coming up with. So like x equals some number. And if we have no solution, that means all your variables are going to cancel out and you'll get something like 4 equals 5, which is false. So you'll have a false statement, and that means there's no solutions. Alright, so before we move on, did you know that a high school once played Justin Bieber's Baby as a fundraiser between classes? The students had to pay to stop it. So $1,000 was actually collected in 3 days, which is actually kind of funny if you think about it. Alright, and let's look at 2 more last problems here. So for this first one, you see parentheses here, and we also see a couple negative signs. So we're going to change those first. And I'll just put this to a plus, a negative 1 there, so we know to distribute a negative 1 to everything. Okay, so let's distribute here. We'll get 2a plus negative 8 equals 4a plus, looks like negative 2a plus negative 4. Alright, if we look on this side, this is very similar to the last problem we did, so we're going to combine our like terms. So 2a plus negative 8, just copying down that side. 4a and negative 2a just gives you 2a. Alright, now we need to move our 2a's together, so it doesn't matter which one we do. So I can actually start on the left-hand side this time, and I'm going to move this 2a right here. So I'm going to subtract it. That'll cancel that out and subtract 2a on this side. So I'm left with negative 8 equals, well, these are also going to cancel out. That equals 0. So I get negative 8 equals negative 4, which is obviously not true. This is false. So that means this has no solutions. All right, and the last problem here. Draw your line down by the equal sign. First side we can just copy down negative 6a plus 3 equals, and we want to distribute, so change this plus to a negative, plus a negative, negative 6a plus 3. Okay, move our variables, so this is a negative 6a now here. So to move it, we'd have to add 6a. This is different than anyone. We've been subtracting variables so far, but we want to add the 6a this time because this is negative 6a. So add 6a. So now these cancel out, so I'm left with just 3 equals. These are also going to cancel out. 3 equals 3. So this is true. So this is an identity. Or all solutions. Okay, and the other easy way to look at this one is if you would have looked at this step right here, the very beginning step, and you notice both sides of the equal sign being exactly the same, you can actually stop there. So both sides say exactly negative 6a plus 3 equals negative 6a plus 3. As long as the signs are exactly the same and it says the same thing, from there you can stop and say that it's an identity. Alright, and that is it for solving equations with variables on both sides. We will see you later.